Problem number 27, it's a picture problem. We're given this picture here. We're asked information, we're asked questions about partial derivatives of f at a and b for this contour map of f of x, y. So first off, at this point b here, what's the sign of the derivative partial f partial x? Is it positive, negative, or zero? Well, let's look at to see what's going on here. So at point B itself, f of b is equal to 3. If we're a little bit over here, let's see, this contour here is f of 2. f of over here, this is less than 3. But then f of over here, this is also less than 3. So as we are fixing y constant, so partial derivative f with respect to x means fix y and change x. We go from something less than 3, we increase till we hit 3, and then we start decreasing again. So right here, this is the graph of f. This is the graph of f of x, y versus x here, supposing that y is held constant. This is a local maximum, horizontal tangent line here. So that tells us that this partial derivative is actually 0. Okay, for part B, now let's estimate partial derivatives at A. So partial f partial x is about like the change in f over the change in x. Partial f partial y, change in f by the change in y. For this first one, we are holding y to be constant. For the second one, we're holding x to be constant. So let's take a look here. So going from here to here, let's see, we're going from 1. So what am I doing right now? I should be clear. I'm figuring out partial f partial x. I'm setting y to be constant, and I'm going to be changing x. So way over here, the value of f is 1. Here, the value of f is 0. Way over here, the value of f is negative. So the first thing that we can tell is that this needs to be negative, because as x is increasing, we're going from like 1 to 0 to negative 1. But let's be a little bit more precise here. Going from like this point A over here, we're going from f went from 0 to minus 1. Whereas x went up by 1, 2, a little bit more than 2 units. And so let's say, I'll just call it a little bit more than 2 units here. And so this would be minus 1 divided by 2.5. This is going to equal negative 0.4. So maybe, you can quibble with that 2.5 estimate here. But negative 0.4 is going to be close enough to negative 0.5 right there that that's going to be our estimate. Meanwhile, let's take a look here at partial f partial y. So now we're going to be moving like this, fixing x to be a constant and then changing y. So as y is getting bigger, we're moving from negative 1 to 0 to plus 1. So that shows us here that the partial f partial y is positive in this case. Let's be more precise here. Moving from like here to here, here to here. Yeah, let's say going from here to here. F goes up by 1 unit. So 1 minus 0. And meanwhile, what's the change in y here? I'd say the change in y is about, going from 0 to there, it's about 2/3. We're about 2/3 of the way from there to there. And so if you crunch this out, you get 3/2 is 1.5. So that's going to be my estimate there in part B. Okay, this is problem 27. Problem 28 here is asking us to, find a linearization. Find a linearization here. How do we go about doing this? So L of xy is going to be, it's a linearization at the point 2, 3. It'll be f of 2, 3 plus f sub x at 2, 3 times x minus 2 plus f sub y at 2, 3 times y minus 3. So our initial point, the partial derivative evaluated at the point in question times x minus 2, where that 2 is the first coordinate of the point. The partial derivative with respect to y evaluated at the point times y minus 3, where that 3 is the second coordinate of the point in question. Okay, we just have to calculate some partial derivatives now. F sub x is going to be 6x plus 5y plus 3. F sub y is going to be 5x plus 2y plus 2. We evaluate this at the point 2, 3, each one of these at the point 2, 3. And so we end up with 12 plus 15 plus 3 is going to be 30. And 10 plus 6 plus 2 is 18. Okay, so now we can finish off part A here. L of xy is, f of 2, 3, we also need to plug in, I guess, I forgot to do that. F of 2, 3, plug in 2 and 3 in here. 3 times 2 squared is 12, plus 5 times 2 times 3 is 30, plus 3 squared is 9, plus 3 times 2 is 6, plus 2 times 3 is 6, 30, 42, 51, 63 if my arithmetic is right. So 63 plus f sub x here is 30 times x minus 2, plus f sub y is 18 times y minus 3. There's our linearization. We are done with part A. For part B, now we need to use this to approximate the value of f of 1.97, 0.32. F of 1.97, 3.02. So know that this point here is close to 3. So this is approximately the linearization evaluated at 1.973. Oops, not 30.2, but 3.02. And so our estimate is going to be 63 plus 30 times negative 0.03 plus 18 times 0.02. And so that would be, let's see here, 63 plus 0.36 minus 0.9 would be 62.46 if my mental arithmetic is right. Of course, on a test, that would be a perfectly fine final answer. Okay, so that is problem number 28. Now let's take a look at problem number 29. So we have suppose a temperature measured in degrees Celsius is on the tabletop is given by this function here. X and Y are units of centimeters. Part A is what contour plot of these choices here best match the function? Well, to figure out that, let's set this equal to k. Let's set this equal to k here and rearrange this in a form, I should say here, k is a constant. Let's rearrange this in a y is equal to some function x form, because that's usually how we are most comfortable graphing things. And so this would be y is equal to 40 minus k minus x squared. And this 40 minus k, that is just a constant here. And so the graph of the function is going to look like y is equal to some constant minus x squared. This is going to give us downward opening, oops, let me make it just a little bit prettier here. Downward opening parabolas centered on this y-axis here. In the region that we are looking at, this is only in the positive x and y-axis quadrant here. So we're looking at this part of the picture, and I think this one is going to look most believable. You can see those look like parabolas, like that looks like circles, and the slopes there are just way too wrong. So choice A is my choice here. For part B, now it's going to be a chain rule. Suppose a small bug position at 3, 1 is traveling, so its x coordinate is decreasing rate of 1 centimeter per second, y coordinate is increasing at a rate of 2 centimeters per second. So use the chain rule to calculate the rate at which the temperature is changing from the bug's perspective. So the change in F is temperature here with respect to time by the chain rule is going to be partial F partial x dx dt plus partial F partial y times dy dt. Let's fill in information here. Partial F partial x is going to be negative 2x. Partial F partial y here is going to be negative 1. Dx dt and dy dt, these are given right here that the x coordinate is decreasing rate of 1 centimeter per second. So that will be negative 1 for dx dt. Y coordinate increasing rate of 2 centimeters per second. That's 2 for dy dt. And so we have this. The very last thing we need to plug in, we haven't used the original point yet, is 3, 1. So that's telling us that this x coordinate here is 3. So you have minus 6 times minus 1, minus 2. 6 minus 2 is 4. And let's put on units here. 4 degrees Celsius per second. A very big temperature change.